Okay, folks, very good evening, everybody, and I'm happy to see all of you today. Today's class, I want to make it as interactive as possible, guys. And today is the last class of the bootcamp, data science bootcamp certification series that we ran. If you are going to attend, I mean, if you have attended all the three classes, then you will get a certificate from us as well. So the reason why I want to make today's class as interactive as possible, because today's class is about answering your questions, any questions that you may have about the data science industry, about data analytics industry, business analytics industry, data engineering industry, anything to do with all these concepts, anything to do with the data career. You can literally ask me any of those questions, and I'll make sure that we cover these questions during the session. Okay, I do have an agenda planned out for today, but feel free to ask me any questions from this industry, and I'll be more than happy to talk about from my experiences, from experiences of working for last 17 years in this industry, and also my experience of working with wide variety of companies which are into data science. So I'll be more than happy to talk about anything about the data industry that you may, any question that you may have about it. So this slide is just about us. We have spent significant amount of time. Ivy Pro School has spent significant amount of time in the data industry since 2007. We have worked with some of the largest companies that you might have heard of: Honeywell, Tata Steel, Coca-Cola, ITC, Saudi Aramco, Tesco, Genpact, HSBC. Significant amount of companies in General Mills, Pillsbury Atta. Exciting companies we have had an opportunity to work with. Yeah, and some 25,000, 26,000 plus alumni that we've had. Now, who can tell me what data science is in the simplest words? Who can explain it to me? Anybody who can explain what data science is, what happens in the data science world? Anybody would like to explain it to me? Anshul, how about you, Anshul?
Surely, sir. So I believe that the data science is very important in today's world because the companies and the institutions are looking for an solution to the problem. A solution to the problem which should have a significant answer that we get through the data.
Okay. So solves business problems using data.
Absolutely correct.
Okay, very good. All right, let's see what I had in my slide. Okay. One of the things that we work in the data science world is that we work with past data as well, historical data. We find insights and patterns, then we make predictions. And then, very, very important, that we take actions, which we call it as a prescriptive analytics. So for example, historic data, so this we call as a descriptive analytics. Right? If you have to relate it with your school level statistics, then mean, median, average, mode, standard deviation, variance, those help you to find what has happened in the past, right? So you do like a lot of root cause analysis, a lot of such analysis, what has happened in the past. When it comes to making predictions, then we call it as a predictive analytics. Predictive analytics meaning, for example, as basic a model as regression model or logistic classification model. So something to make, something where we say what may happen in the future, what might happen in the future. There we'll learn a lot of machine learning algorithms as well, and so on and so forth. All those things come under over here. Then finally, we have something called as prescriptive analytics. Whereby we take actions, what might happen in the future, what actions to take based on what may happen. I always try to take an example of a doctor to explain, data science in the simplest word. When you go to a doctor, the doctor says, all right, what are your symptoms, right? He may take his stethoscope and he may try to look at your your symptoms and look at the signals that you're giving. So that is historical data, meaning what has happened already with you, right? He's trying to solve a problem, that he's trying to see, look for the patterns. Have you had this kind of a problem? Let's say you go with a lot of cold and cough, God forbid. So the doctor would say, all right, have you had this kind of a problem multiple times? And how often do you have them? So he's trying to see if there is a pattern here, right? If you say that, yes, every 3 months I have it, then he would say probably there is something allergy. Maybe you live in an area or you work in an area where some allergen is there and we are allergic to. And hence he's trying to generate some insights and patterns around it. Then you may ask the doctor that, but what do you think? What is the prognosis? What might happen in the future? For that, he may say that, all right, let me make some prediction. But before he makes prediction, he may also tell you that let's collect more data. And how would he collect more data? He will collect more data by prescribing you a certain test, right? Once the test reports are there, then based on his medical understanding, he will say, based on these tests, I can predict that, maybe you will be fine in 3 weeks time. Or I can predict that you may have to take these actions, right? These medicines and so forth. So based on your historical data, based on the insights and the patterns, based on all these things and based on what might have happened with the patients like you with the same similar sicknesses, he will then make predictions. And then accordingly, he will prescribe you medicines, which we call it as action that he will take. So in any profession, whether it is medical profession, whether it is a lawyer, whether it is in the world of business problem solving, in any profession, the problem solving happens the same way, that you start with historical data, you try to find some patterns, you then make some predictions about the future, and then you take action. And that's exactly what data science is. In data science, we learn a lot of tools, a lot of concepts, some bit of mathematics, which will help you understand what has happened in the past. Then we also learn some machine learning algorithm, deep learning algorithm to predict what might happen in the future, right? And then some techniques to prescribe actions. That's what we do in the world of data, in the world of data science, right? Essentially, you are helping, as Anshul said, you are helping solve business problem using data and information. Is it making sense, guys? Yeah. Now, thank you, Apratil. Now, think about this. Which here we have spoken about data science as that means you are the consumer of the data. You're consuming the data to make business decisions, but who's the custodian of the data? Who's ensuring that these data science folks have access to the entire data infrastructure? That is where data engineers come into the picture. Or nowadays we call them as cloud data engineers. These cloud data engineers are those folks who make sure the technology infrastructure is up and ready, is seamlessly accessible by the data science folks who can then use the data to make whatever decision that they want to make. So why do we call them as nowadays cloud data engineer? Because most of these data infrastructure is created on cloud. And hence the word cloud comes into the picture. For example, if you remember yesterday, we worked on Google Cloud Platform. And then I had given you a link to my tutorial, where I spoke about how can you host databases on Amazon Web Services, on Microsoft Azure, okay, or on GCP, Google Cloud Platform. All the data that we end up storing, all the technology that we use in today's time in the world of data, right, is hosted on the cloud, and hence cloud data engineer. So I always say that these cloud data engineers are the people who are responsible for making the buildings. If you were to compare with an analogy from the real world, and the data science folks are those folks who are actually living inside the building, who are the actual users of the building. So the data engineers are those people who would ensure that all the technology stack infrastructure is ready. And the data science folks are those folks who use the data which is residing on the data technology stack to make business decisions. Now, that is the actual distinction between a cloud data engineer and a full stack data scientist. However, the difference between the two can merge. The distinction between the two can be blurring, can blur, especially when you're working with a startup or a high growth organization, like but smaller organization. If you're working with a very large organization, there will be a distinction between the data engineer and data science folks. But when you're working with a smaller organization, the distinction between the two merges together. Okay, but both these areas, data engineering, cloud data engineering space, and the full stack data science space, both these areas have huge demand in the industry. Okay, now some of the application areas, I'm sure a lot of you guys already know about it. I'm not sure. Okay, all right. Some of the areas where data science industry, data science folks are used, I mean, you can literally see healthcare, all the industries, retail, finance, network management, log analysis, search quality like Google, Bing and all, telecom, traffic control, security, homeland security, manufacturing industry, trading analytics, algo trading, fraud and risk, banks, retail industry. So, and in, I mean, IB, we've had almost customers or clients, official clients from all the different areas. You know, there is, you'd be surprised that there is government of India also we work, or our students work with extensively to help them solve various different problems related to security, related to financial control, related to fraud detection, income tax fraud detection, related to transport, traffic management, and so on and so forth. There are a lot of companies that we've worked with where we've helped them solve telecom churn analysis or telecom related problem, algo trading, manufacturing like Tata Steel, ITC, Honeywell, retail company like Tesco, Spencer's, and so on and so forth, HSBC, where they work a lot on fraud and risk analytics. So you would see that all these areas have huge application of data science. But one of the very interesting things that a lot of people do not know, if I were to ask you this question, out of all these industries that you see on the screen, which industry do you think is the industry which hires the most number of data scientists? Which industry hires the most? Any idea? Subhrangshu says healthcare. My answer to that would be no, although healthcare has good applications.
Financial institution.
Okay, Abhijit is saying financial institutions. Perfect. But why do you think, Abhijit, financial institutions? And why not, Sanjukta, you're also right. Why not other industries? Why am I saying that financial industry or banking and financial industry is the highest? You can see, you know, risk analytics, financial analytics. These are all part of BFSI domain. Why do you think most jobs are from these industries? What is the reason? What do you think? Anybody?
Because every day they are generating data.
Every day they're generating, every day everybody is generating data, Shahid. Every day strategy analytics, every day e-commerce companies are generating data, every day healthcare companies are generating data, every moment of the day, all these kind of companies are generating data. But why specifically BFSI industry hires the most?
What I think is that it may be because since finance companies are related with a lot of transactions, so a lot of risk is there, and number of fraud cases is there, which is very important to detect at a very early stage. So analytics is very important for that field.
Okay. Well, Sanjukta, you are right, partly that the stakes are higher, right? I mean, any financial fraud that may happen may result into a lot of loss for the financial organization. But you know, there is risk in healthcare as well. There is risk in many other industries. But in BFSI, one of the reasons why they have been traditionally the biggest industry which hires the data science folks or data engineering folks is because of the quality of the data and the quantity of data that they have. Why do they have very high quality of data as compared to maybe other industries? Why do you think that they have better quality of data accessible? Any idea? Why am I saying that BFSI industry, the banks, the financial companies have better quality of data versus, let's say, retail or commerce companies that we are talking about? Any idea, anybody? No? Okay, let me tell you. Very simple point to understand here is, when you go to a bank, right? Let's say you're opening a bank account, new account. Would you ever give a fraudulent data point here? Would you ever fake your email ID or your phone number or your PAN number? Would you ever give any fake data? You would not. And even if you try to do it, they will not accept it because they will do KYC or know your customer. It's a government's regulation nowadays. All the central government across the world have this kind of regulation. So you would never fudge your data. You would never give fake data to a bank or any financial company. And they have, by the law, they're supposed to get accurate data on their customers. But similar laws are not there in e-commerce company. When let's say you open e-commerce account in Flipkart, let's say you end up giving wrong last name spelling. Nobody's going to say anything, right? You end up not providing your genuine email ID. They will not say anything, right? You go to a Pantaloons to buy something. You don't give your phone number. The cashier will not say that I will not sell you this thing, right? As long as you're willing to pay for it, the cashier will say, all right, no problem, sir, you can take it. When you go to a hospital, a lot of people in India would not even disclose because they're going to pay by cash. They may just say, my age is X, my name is Y. Nobody's even going to bother. They don't ask you, show me your Aadhaar, then only, we will treat you. They don't do that. But BFSI industry, all the banking and financial companies will always have most accurate data on their customers. So that is the quality. With accuracy, higher accuracy meaning higher quality of data, that means any decisions that they would make on that data, their decision would also be of higher quality. Is it making sense? Right? Second, quantity. Sanjukta said that they have access to a lot of transactions. Every day we are doing transactions. You use your debit card, credit card, or bank account or UPI to pay somebody. The moment you do so, the bank comes to know who you paid, what kind of entity or what kind of merchant you transacted with, whether it was an insurance company, whether you paid for your life insurance, whether you paid for car insurance, whether you bought a car, whether you bought jewelry, whether you bought a flight ticket, train ticket, anything, they know that. Since they know all this high quantity of data that that the banks have or the financial companies have, when they make decisions using such data, the decisions are significantly better result giving, right? Hence, we always say that BFSI industry is the biggest industry which hires in the field of data science or in data engineering as well. Most of the clients that we work with, most of the consulting and the training projects that we do are also related to either consulting companies which have a bigger BFSI domain and so forth. Risk analytics is such a large area. Financial fraud analytics is such a large area, and also banks also have marketing analytics within them, because again they have accurate data. So whatever business decisions, marketing decisions that they make on the basis of the data that they have are also very, very accurate. Right? Any questions on this, guys? Any questions on this? No? Various roles in the world of data. So you would have seen there are various sub roles which are available in the world of data. MIS reporting analyst, we'll talk about it. What are the tools that they look, what are the skills that they look for is Excel, SQL, VBA. What kind of work do? They essentially create reports. So if you remember descriptive analytics, they will look into what has happened in the past. They will create fancy reports as well. They will essentially work with Excel, SQL, automation of data. But they're not the people who would work on what may happen in the future. Then we have data visualization analysts. Any guesses on the skills that they look for, or any guesses on the tools that they need to know? Any guesses?
So
Sir,
Python,
Power BI,
Power BI. What else?
Tableau.
Python, sir,
Okay.
Python.
Python as well, but Python data visualization, you have to write a lot of codes. But with Power BI, Tableau, Google Studio, Data Studio, you can do visualization stuff very quickly. Hence, they of course need to know Excel, SQL, and Tableau, Power BI. I don't know why I have not written Power BI. Power BI is big right now. Excellent tool, very, very famous. Microsoft is promoting it, is giving it at a very cheap rate to all its client. And people are familiar with Microsoft products like Excel, Word, PowerPoint. So they also end up buying Power BI. AWS QuickSight, but ClickView, Apratim, yes. In fact, with HSBC, with Affine and all, we have trained a lot of people on ClickView. But believe me, what happens with ClickView is that the market share is still low, not as high as Tableau and Power BI. Then predictive modeler. These guys are quantitatively heavy. They know their statistics very well, right? And so Excel, SQL, exploratory data analysis. Not in this particular boot camp, but in most of the other like monthly boot camps that we do, you would notice if you go through our YouTube channel, you will notice that normally we also do a session on exploratory data analysis. And I can send you another link for exploratory data analysis, where we basically again try and see what has happened in the past, but with some kind of VBA code or Python code or a SQL code, right? We try and make patterns, insights from large amount of data, right? But again, historical. So it's still part of descriptive component. Then for predictive modeling, we have to go deeper into statistical algorithm, machine learning algorithm. You got to know at least one of these machine learning tool, or tool which supports statistical or machine learning algorithm very easily. Python is of course the leader here, but R is also used quite significantly. SAS is also used quite significantly by financial and pharmaceutical companies. A lot of retail companies also have SAS. A lot of financial companies also have SAS. But yeah, predictive modeler are people who predict what might happen in the future with the help of machine learning and statistical algorithms. Big data analyst is somebody who works on all these, but not so much on stats. Although I've written stats, but not so much on stats. But they're very good in big data Hadoop system. But a lot of this is now getting changed into something called as data engineering role, which also I will talk about. Data science is somebody who knows all of these. Very rare, but that's what the data science person is. Can work with large data, can apply all the machine learning algorithm, can do data visualization as well. Rare to find, difficult to learn, because you just have to learn so many things. Then one of my other favorite these days is cloud data engineering. A lot of openings have come in the recent past, guys, because these are those techies who support the entire data infrastructure. So they also need to know SQL, definitely. They need to know Python. They need to know cloud. They need to know how all these things can be implemented in AWS or GCP or Microsoft Azure. They need to know these things, right? Unstructured data, they got to know how can we work with unstructured data. They need to know Apache, Spark, Scala, Snowflake. Essentially, those things which either allow you to host large amount of data in a cloud data infrastructure, or allow data science guys to access data on a real-time basis without any errors. So they are technology oriented. But if you notice, right, SQL, Python are common with the data science folks as well. So there is overlap between them. Again, as I said, if you work in a startup, then even if you're working as a cloud data engineer, they may expect that you do a little bit of this as well. They may ask you that, all right, you can easily do data visualization. They may say that, all right, you can learn you can run some machine learning algorithms as well. So they may say so. And similarly, if you're working as a data scientist in a startup or a mid-sized company, they may ask you to do a lot of these things as well. And hence in Ivy's program, the way we have designed a program is that a few things are common between cloud data engineering and full stack data science people. For example, SQL, VBA, Excel, Power BI, or Tableau. These are common between them, right? We also recommend that anybody who's doing, so these become like common modules. And then after that, you can choose your specialization. You can go to data science, you can go to data engineering segment. Any one of these two verticals, you would have great success. It's about your interest, whether you want to work behind the scene on the technology space more than you want to work in front of the scene, helping people understand how to solve problem with the help of data. So data science guys, they are not behind the scene generally. They are in front of the scene, helping companies make decisions using data. Data engineering guys, they are generally the people who are behind the scene, but they are also they're ensuring that every component of the data infrastructure is working smoothly. Otherwise, the data science folks will not have access to the data quickly. What is the role of Keras and TensorFlow? So what TensorFlow and Keras do is that they help you automate a lot of deep learning algorithm implementations, Ashish. So that is also part of the job that Crypto Modeler or the job that data science guys do, which is again work with huge amount of data. Imagine all the Google search queries that happened in the last 1 month, right? If you're working with such huge amount of data, then you need deep learning algorithms which are not statistical in nature, but which are more quantitatively heavy in nature. For example, I'll give you a very simple example of how TensorFlow. Okay, what is the difference between machine learning and deep learning? I will give you with. I'll give you with an example. Let me open a whiteboard around it. Good question that you guys have asked. A good question that Apritam that you have, Arya that you have asked. Let me open my whiteboard and let me explain it to you what this means. Okay, give me a second. I do have the let me see. Okay, no worries. It's not loading. I will explain it to you here only. So the difference between machine learning and a deep learning models is that, imagine this is a circle, imagine there is another circle, and imagine there is yet another circle, right? Now, this part here is deep learning. This part here is, say, statistical models or statistical learning. This part here is machine learning. The difference between the two is, and machine learning includes statistics as well. Or let me put it like this. Let me put it like this. This part is machine learning, and this part here is data science. Let me put it like this. That is a better thing to explain. Machine learning models help you predict what may happen in the future, predict future with the help of popular statistical models. That means there is an estimation error, because any statistical model would have some estimation error because it would work with a sample of data. Okay, imagine if you're talking about that, let's say LinkedIn has 500 million users, 500 million users, right? So if you want to do some analysis, we will not work on all 500 millions of users. We will take a sample of it. Let's say we will take 5 million users, 50 lakh users, random users, and we will say that whatever is true in these 5 million users, let's say you want to find out how many males and how many females are there, right? How many experience, how many are fresh college grads among all LinkedIn users. So we'll say that, okay, we will work with this sample of users, and whatever is true for this sample of user would be true for the overall set of users. So this is statistical in nature. That means we are trying to predict future based on a sample of data and what has happened in the past. Deep learning models, on the other hand, for example, CNN, RNN, KNN, all these models, right? They rely mostly on something called as almost a brute force analysis. Brute force analysis basically means that they say that give us huge data. Give us huge data, and using typically neural networks. That means, I don't want to go into too much details about neural network, but essentially give us huge data. We will make that data go through a black box algorithm, which is based on generally neural nets or neural network, and we will give you output. Give us huge amount of input data, input training data, we call it as input training data, and we will analyze that, and then we will give you prediction or predictive data, which will be highly accurate. Highly accurate outcomes. Outcomes. Now, I'll give you an example of a deep learning algorithm. Let's say you go to Google and you search for cat images, right? You go to Google and you search for cat images, and you get, let's say, 1 billion hits, right? Now, imagine there is a person who has just come from, let's say, who was living in a room for 10 years, for last 20 years. An adult who was living in a very confined space for last 20 years. He has not seen any cat ever in his life. He has never seen any cat. Now you say, and you're trying to train that person about cat, how cat looks, what are the features of the cat, what kind of animals are cat and what kind of animals are not cat. So you say that, what, let's sit in front of the screen. I have searched image of all the cat. Please go through all the billion images, each one of the billion images. I don't care if it takes you 1 year to do so, but please go through 1 billion images of cats. By the end of this 1 year, once he has gone through all the billion images of cat, he has made all the notes about it. Arya, what do you think will happen then? What do you think will happen if this person would have gone through these 1 billion images of cats? What will happen, Arya? What do you think? What do you think will happen, Arya? Don't you think that this person who would have gone through, so Arya is saying he might be able to differentiate to a large extent. He or she, even if you give him a cat which looks like a dog, he would then be able to very confidently say that, no, this is my drawing is bad. Let's say this is a cat. I can tell you with guarantee, with almost 99% surety, that this is a cat. Not 100%, maybe 1% error, 99% surety, this is a cat. Now consider, so this is, this model, this kind of a training exercise, then we will say that is a deep learning training model exercise, right? Now consider that if it is a general human being, right? I mean, you would say that, all right, I don't want you to go through 1 billion images. Even if you go through 100 cat images that I can randomly find on Google, go through 100 random cat images, right? And then you should be with an accuracy of, let's say, 80%, you will be able to tell or differentiate a cat from a dog, but not with 99% accuracy. But with 80% accuracy, you would be able to tell the difference between a cat and a dog, right? Now, Arya, then let me ask you this question. If these two approaches are there, which approach would you prefer? Suppose you are the trainer, right? Which approach would you prefer? Would you prefer this approach, or would you prefer the deep learning approach? So Arya is saying first approach. What about the rest of the class? Which approach would you prefer? This deep learning approach, whereby, this approach whereby, the person who was being trained had to go through 1 billion images and had to take 1 year to do this, which we call it as a deep learning algorithm approach, versus this machine learning algorithm approach or a statistical algorithm approach, which let's say took maybe 1 hour to do it. Which approach would you prefer? Rest of the class, I have asked Arya. She said she prefers this approach versus the deep learning approach versus the machine learning algorithm approach. Which approach would the rest of the class prefer? Anybody? Khushbu, Saheli, what do you guys think? What do you think? So Sanjukta, Amit, all the people are saying that we may end up preferring the machine learning approach. Subhashish and so on and so forth. Because why? Because you are saying that, all right, this guy is 80% accurate, but it took significantly lesser amount of time and resources. This deep learning algorithm does give me very high accuracy output, but at the cost of time, at the cost of resources. And in order to train somebody so accurately, you needed 1 billion hits. You needed 1 billion distinct cat images. Whereas in this approach, you just needed 100 cat images. The amount of data required to train a deep learning model versus to train a machine learning model, which is more statistical in nature, is significantly different. Hence, deep learning algorithms, which rely on almost a brute force method, is highly accurate. Highly accurate, as I said, right? They will give you highly accurate outcome, but is extremely expensive in terms of time it takes, in terms of computational resources it requires. And there should be enough data available in order to train a deep learning algorithm. Otherwise, the deep learning algorithm will not work. Plus, other difference between a deep learning algorithm and a machine learning algorithm is deep learning algorithm is very difficult to explain why this person is thinking that this image is a cat image. He cannot tell one reason. He cannot tell 5 reasons. He may just say that in my memory somewhere I have seen a cat like this. I can't really remember where, because I've gone through 1 billion images. So I don't know which image that I'm going to talk about. Whereas any statistical algorithm, any machine learning algorithm can very confidently say that I am recognizing this person, this animal, as a cat animal, because it meets these 5 features that I saw in these 80 images that I have seen so far. So, which we call it as reasoning. If I'm a business leader, if I'm a sales analytics, if I'm a vice president in sales, and I want to understand what could be my future next quarter sales, right? Suppose a data analyst comes to me, data scientist comes to me and says that, you know what, I think the next quarter sales will be $100 million, and I am 80% accurate and I'm 80% confident. Versus a deep learning data science person comes and says that I'm 99% sure that your output, your sales will be $88 million. But if the vice president sales asks this deep learning data science person to explain why he thinks it will be 90% accurate, 99% accurate, this person will not be able to give the reason. Why? Because this guy has run a deep learning algorithm which is so complex, and it has gone through so much of training data that it is very difficult to understand why, when, where, how did it identify that it'll be, that outcome. why it is so highly accurate outcome. So as a vice president of sales, I may just say that, no, I'm not confident. If I don't know the reason why you think you'll be 99% sure that that will happen, I would rather want to go with somebody who's 80% sure, but can give me the reason why it would be, why he's 80% sure. So that is also one of the reasons why, other than of course cost and the availability of data and the availability of such heavy computational force that is required for deep learning algorithm, that is one of the reasons why a lot of companies still prefer to use machine learning algorithm, even though the accuracy levels are much lower than the deep learning algorithm. They don't have access to data, they don't have that much of budget, they don't have resources, I mean computational resources like processor, cloud space to actually run deep learning algorithm. Hidden layers, that is the problem. Hidden layers are significantly more. This neural network, it may have a lot of layers in a deep learning algorithm than a machine learning algorithm, which is more statistical in nature. So that is a difference. Both the kind of job would be part of a data science world, but the nature is very different. The algorithm that we end up using is also very different. Companies like Facebook, LinkedIn, Google, which have huge amount of data available to them, which have huge data infrastructure, cloud space, cloud computation resources also, they don't mind running a lot of deep learning algorithms in their own data. But if you ask the bank, a bank may have what, how much, maybe 1 million transactions happening in a day. But if you consider Google, they may have a few million transactions happening every second, right? So that is the amount of availability of data differ quite drastically. And if the data is not too much, then the deep learning algorithms you will find very difficult to train the deep learning algorithms. Whereas you can definitely use machine learning statistical algorithm to train your decision-making model. Good question, guys. Very good question. One of my favorite questions as well. Coming back over here. So, as we said, I mean, there are career opportunities available for everybody. And this is one of my other slides that I like to talk about. Which role is suited for you, for me? I mean, somebody who loves statistics, work with numbers, likes to work with numbers, predictor modeler, machine learning model. Somebody who loves statistics and also mathematics a little bit, and also love a little bit of coding, although coding is SQL coding, Python coding, that kind of coding, not like a C++ or Java coding where you have to build softwares, right? So that person, I would rather say that, okay, you can actually get into data science world, or you can project yourself to become a data scientist. If you're not so much into statistics, but you love SQL, you're decent in programming, you call yourself a techie or you're a tech-oriented person, then become a cloud data engineer. Promising career, guys. A lot of openings. Okay. Your statistics is okay kind. You do not hate statistics, but you're not also a lover of statistics, right? Then you can go into the Power BI hardcore data visualization stuff. A lot of our students have made strong career in data visualization just by being very, very specialist in the data visualization world. So this girl, I mean, I've redacted her name, but she was a BCom grad, fresh college grad from with BCom degree. But by the end of the program, data science program with us, but she focused mainly on data visualization. And all her resume, if you can notice, these are all data visualizations, data storytelling project, and she got great success. I mean, her profile, you can also see it on LinkedIn, and she had an amazing set of opportunities because she focused. And she said, I'm not very good in Python, I'm not very good in machine learning models or statistical algorithm, but I'm good in visualization. So then she focused a lot on this side, and then she got great success. And she was part of our students community and huge success in her career. So Anurag is saying good in stats and maths, but no idea programming. Literally, Anurag, learn programming. It's really, really, if you're good in stats, programming will be like baby thing for you, baby step.
Sir.
Yeah.
Hello. Shubhanshu.
Yes, sir.
Sir, I do have one query.
Sure.
Sir, I'm computer science graduate but in the year of 2009, I have completed my computer science. After that, I shifted to pharmaceutical sales. More typically, I'm working as a medical representative in vaccines and pharmaceutical industry. Now I have almost 9 years of experience in sales and marketing, and now I think that I'm trying to take a transition from pharmaceutical marketing and sales to other industries. So, is it suitable for me? Data science course is suitable for me or not?
See, Subhranshu, the way I like to explain this question is, right now in IB, I mean, we just finished one, I mean, we've been working with large corporate houses. We finished one project with one of the largest retailers, with one of the largest solar manufacturers in the world. In all these projects, we actually trained huge number of CXO level people, director of sales, director of finance, director of HR, director of operations on data science, Subhranshu. So what I'm trying to say is that in data science world, right now the opportunities are immense. Whether you worked in sales, whether you worked in finance, there is opportunity of applying data science in sales analytics, in customer analytics, in marketing analytics. So if somebody comes with a particular industry domain, I say that don't change your domain, be in sales analytics, but apply data science, learn data science vocational skills so that you can work as a sales analytics professional. With your kind of background, you would have immense industry understanding, how sales works. And with that, if you include some of these points, right, some of these skills, then you become a hardcore sales analytics person and then represent your profile. Build your profile like that, Subhranshu. Don't try to sell then your pharmaceutical sales, but and pharma industry is a big industry and they like to hire people from within their own industry. So if you are in pharma industry, you understand how drugs work, you understand what are the labels, what are the data labels about drug, what is the meaning of what data point within the pharma industry. Then, and if you know how to apply data science, right, then it becomes a strong profile to go with. But if you're trying to switch your profile from pharma to finance, then it would be a wrong thing to do, Subhranshu.
Okay.
You understand, Subhranshu, what I'm trying to say?
Yes, sir. Yes, sir. Yes. But actually, I want to move from pharmaceutical industry, so that's why
But
I'm thinking.
Subhranshu, if
I'm
I'm
a
in your
typical
place,
field-based person, sir. I'm a typical field-based person. So
I understand,
just,
Subhranshu, but
yeah.
you see, ask yourself, even if you've been into the sales, you understand what is the meaning of a medicine? What are the data points about medicine? Do you understand? You understand what is the difference between an antibiotic versus a cough medicine, and what really happens in it? I tell you, my roommate from the US, this guy ended up joining this company, which is big in pharmaceutical marketing and sales analytics. Their main specialization was that. It's there in India now as well. ZS Associate or ZS Associate as it's called. Just Google and understand about this industry. You will find the biggest industry this consulting company caters to is pharma sales analytics. There is a huge need for people like you who understand pharma sales and who also understand data analytics.
Okay. Okay.
Yeah, I mean, that's right. I mean, people start as a data analyst or a business analyst and they move into data science. That's a very typical thing that companies, people do. So, for example, let's say somebody who, somebody who starts here, then they end up learning data visualization. They also end up learning statistics part of it, and that's how they get into from being a pure data analyst to being in the data science track. What is the role of Apache Spark? Although I'm not an expert in Apache and Spark, but essentially, Avijit, what happens is when you are working as a cloud data engineer, you need set of tools and technologies which will help you access huge amount of data, error-free and in real-time basis, almost as quickly as possible. And that is where these tools come into the picture, these languages come into the picture, Avijit. Okay, I mean, in fact, remind me to send you a video link where I would explain you. I mean, we have explained everything about this Apache Spark and what are the things which happen in the cloud data engineering space, and I'll be more than happy to give you that link. One important thing before we finish the time, guys. After MBA, which is better, business analyst or a data analyst? Well, I mean, after MBA, who's the name? What is the name? Shahid. After MBA, I mean, the idea is it's not about, you see, after engineering, after MBA, you can go into business analytics if you like to solve business problems. Then I would say that you can become a predictive modeler as well. You can actually become a data scientist also, or you can be a pure play data visualizer. A lot of people, I mean, so that also depends upon your interest. Is your interest into solving business problems and representing data and slicing and dicing data? Then I would say data visualization, MIS reporting. And also, if you have not hated statistics in your life, then add machine learning or statistical algorithms as well to it, so that you go into the data science path completely. Sibashi's SPSS software by IBM is almost dying. Sibashi's used by some of the marketing analytics intelligence companies. At one point of time, Ivy was an IBM partner as well for training on SPSS as well. But I mean, I have not seen any of our clients using it. Let me put it like this, Subhashi.
Sir, Shubhanshu again.
Yeah,
Yes, sir. So, sir, for then what type of data? Data analysts or something, data science. Which type of career should I choose?
I would say that since you're beginning your career, so I mean, or you want to switch your career, so you can actually try and do, in Ivy we run one program called as data science with data visualization certificate. Subhanshu, somebody who's great in reporting, somebody who's great in visualization, somebody who's decent in statistics, not so much in the cloud data engineering space at all. Subhanshu, I would not recommend that.
Okay, so data visualization is the best for me.
Data visualization along with some understanding of statistical algorithms, Subhanshu. You can't really completely avoid it, because then you'll be limiting yourself quite a bit.
Okay.
So if you were to talk to any of our counselors, then ask for this program called as Business Analytics with Data Visualization program.
Okay.
All right.
Sir, I'm a graduate in economics.
Yes,
so what program will be the best for me? What program I would choose? Data science or a business analytics program?
I would say data science with AI and ML. We run a program with Government of India, which we call it as data science and with AI and ML. Why am I recommending this? Is that AI and ML, we've spoken about ML. AI is the deep learning part. Deep learning may be little stretch for you, but I'm going to recommend deep learning to you, Anurag, because you're not going to be scared of numbers. You're not going to be scared of statistics. So you can stretch a little bit and learn the deep learning algorithms as well. So we have a program called as data science with deep learning and ML algorithms. That is going to be, and that also includes data visualization. It includes business analytics. It includes statistics, Python, SQL, R, Excel, VBA, MySQL. So it includes Power BI. So it's a very nice program. And we have had huge success with people who come with economics background. All right, before we finish the program, guys, I really want to talk about some of the very simple steps that I recommend, whether you are getting into data science world or data engineering world. I strongly recommend these steps because we have had huge success with these steps. Okay, learn statistics, learn SQL, learn Python. Okay, learn a little bit of cloud as well in today's time and space. These are fundamental things, guys. Anybody who wants to get into data world should know some of these things very, very SQL, Python, some cloud, some statistics. Everybody should know some visualization tool, whether it is Power BI or Tableau. Got to know that. when you learn these, remember to work on projects. Any of your resumes that I would show you of any of our IB successful students, the first page is filled with only projects, and be intelligent about these projects. If you notice, she has given very small description and links, public links. All these projects are hosted on our LinkedIn profile as well, or IV's YouTube platform. This is the portfolio and online competition. So that's what I'm recommending here. Work on projects. As part of the program that we run in IV, we make you work on projects in every module, at least 3 projects in every module. And participate in online competitions. We strongly recommend our students to participate in online competitions. So if you see her profile, remember she was a BCom fresh college grad, and she ended up having 5 to 6 different roles by the end of the program. Online competition in visualization and Tableau, and it's not about winning, but it's more about being out there, publicizing your skills. When you participate in these online competition, you get badges, you get social profiles, and when you put them on your LinkedIn profile, on your resume with links like this, then any recruiter that is hiring you, right, would be very interested in understanding who you are, very interested in seeing what you have done. So online competitions, very, very important that we recommend. Then create a project-based resume, something like this that I was showing you. This we call it as a social project-based resume because there are social links given to these projects. And if I open any one of these projects, hundreds, 200, 300, 900, 300 people have liked and spoken about these projects. When you do so, then you are making your profiles viral, your skills viral. It's like when a recruiter looks at your profile, looks at a resume like this, the recruiter may not open all the links, but at least will open 1 or 2 links. And when he or she opens such links and sees that 200, 300 people have liked it, 100 people have liked, 50 people have also liked it, then he will get huge amount of confidence to call you for an interview. And this also gives you a lot of confidence about your own project works. And it's like buying something off Amazon. The first thing that you look at is reviews. This is how you're making your skill viral and asking people to give you reviews. And when that happens, any recruiter would be more than happy to call you for an interview. So this is something that we call it as a project-based resume. That's what we mandatorily do. Post projects on LinkedIn. LinkedIn is the only platform that works for job seeker these days, guys. Please, please, please. When you know something, please talk about it. All our students do that. We encourage our students to do it, right? Start networking on LinkedIn. And then finally, shortlist the companies and apply. When you do something like this, most of the time, you don't even have to shortlist the companies will shortlist you. You'd be surprised how many times we have gotten requests from company founders who want to hire people from us just because they have seen projects by our students on LinkedIn. In fact, on a YouTube platform, we run a specific YouTube channel, YouTube playlist, whereby we have given some of the key projects done by some of our students, and you'll be surprised. So industry projects done by our students. Just go through this playlist. You'd be surprised how many people have done so many different projects, and tens of thousands of people have liked it. Look at this project. She has done this project, and almost 9,500 people have liked it. 9,300 people have liked it. So when you do projects like this, and so many people end up liking your projects, automatically, right? 215 people have liked it. Automatically, when you give a link to such projects on your LinkedIn profile, you become popular. So the companies, instead of you shortlisting companies, the companies will end up shortlisting. That is the model that works in the industry, guys. Okay, and I'm telling you, this is how the successful people are successful. They're smart about the skills that they know. That is what I strongly recommend. And the last thing, if anybody of you are interested in the courses, then these are some of the courses. We also run a very unique program. Many of our courses come with a pay after placement support as well. If you're a meritorious student, if you're competent and so on, so forth, if you're interested, you can always talk to one of our counselors. Cloud data engineering is a very unique program that we do. We also preparing for international certifications. Data science with machine learning and Tableau with NASCOM and Government of India certification. AI and deep learning course module as well. So I mean, various programs for every role that we spoke about. We have a program. But I mean, if you would have any questions about the programs, feel free to ask me. Or I mean, I'm going to give you my LinkedIn profile. So if you just Google Pratik Ivy on Google, then the first hit that you will get would be my LinkedIn profile, and the second hit would be my Twitter profile. I'll be more than happy to get connected with you and answer any of your questions that you would have. Or you can definitely reach out to any of our academic counselors, and they'll be more than happy to answer. So that is what I had as part of the scheduled agenda for today's session. I am going to be available for the next 4 to 5 minutes. Should you have any questions, I'll be more than happy to answer. Amit has asked one question, that he's an MBA graduate and how can data science good for me? Why not? Data science is good for anybody these days. Okay, I mean, anybody, any business person is not using data is unheard of today in today's time. All the business decisions. As an MBA person, what do? You help businesses solve problems, right? Or you help businesses market well, sell well. Any of such problems that an MBA person solves for a business is done using data these days. So any MBA person has to know data analytics. Must, but has to know. I always say that data analytics in today's time is like communication skills of 90s for MBA guys. If you're an MBA person, you got to know data analytics in today's time. Like how people used to say that in 1990s when we were in college, right? That people used to say that you have to have, if you want to become a great professional, then you got to have great communication skills. In today's time, in this century that we're living in this decade that we're living in, data analytics is the only skill that you need to have if you want to become a great professional. Is understanding of AWS very, very important for becoming a data analyst? Not necessarily, but Sanjukta, most of the things are happening on cloud. Hence, it's not rocket science at all. If you attended my yesterday's session, we did all the things on Google Cloud Platform. At least that platform was very easy to use. Hence, if you go through one of my videos on using Amazon AWS or Google Cloud Platform to run SQL BigQueries is there on a YouTube platform, you will see it is not difficult at all. So don't be scared of cloud. It is designed to be easy. So it's not really a must, but it is highly preferred, I would say, Sanjukta. At least to all our students, we strongly recommend it. All right, great, guys. Thanks a lot for attending today's session. It was great having you in today's session, and thanks a lot for asking all those questions that you guys asked. And whoever joined us for all the 3 days, they're going to get certified. Congratulations to you as well, and I hope you guys had a great time. Do try to connect with all the faculty, coaches that you must have interacted with on LinkedIn. Remember, everybody has spent on an average more than 10 years in the industry. Build professional network with these folks, guys. You'll be benefited. Thank you guys for attending the session. Have a good one.
Thank you, sir.
Bye-bye.
Thank you, sir.
Thank you. Bye-bye.